Question 39 is about nuclear reactor, about nuclear reactions, and here is about a specific kind of it. That is the fission. So what is fission nuclear reaction? It will be like you going from a really big nucleus, for example, of the uranium, which have like 92. You remember what is the number of this one, right? This is called the atomic number, right? Because that will be the number of, yes, that's right, of protons, which is a particular number, a unique number for different element. So like if we got it's 92 is uranium, if you got it like 36 is like krypton, or if you got it like 56 then is barium. Okay, so different element will have different atomic number, and the number above here to the left of the element symbol here, that should be the number of the nucleon, okay, of the nucleon. So all the particles inside the nucleus, which involve the proton, that's right, the one that have the positive charge is like plus 1 unit charge, and also of the neutron itself too. The neutron, does it have any charge? No, right? It doesn't have any charge. It's neutral. That's why it's named like neutron. So we can see here these are a neutron, and which is shot at a really high speed, so that it have a lot of energy to go with it. It can attack the nucleus of this one and then make this one to be broken into two smaller pieces. Okay, so that's why from this reaction itself, this is the fission reaction. From one big nucleus you got two more nuclei smaller. Okay, and it also releases more neutron, and then the other neutron being released at a really high energy, at a really high speed, it keep continue and then attack other like uranium nucleus that in the reactor. So that's why we can see this one just happen to be a chain reaction. Okay, here they ask us to find what is the possible value for the NC and the N1. NC is basically the number of neutrons observed by the control rods. So then we can take it out from the reactor. And the number of neutrons that are lost through the wall is the N1 per fission here. So basically here we have four neutrons being emitted per fission. So in this figure you can see that only 3, right? But in this one it means like 4, so we should have like 4 of them. And they ask how to maintain a steady reaction. What does it mean by a steady reaction? Steady reaction, it means that just after one reaction you have another one. So you can keep the number of the reaction under the control kind of steady. It doesn't increase, it's not decrease. So we just keep it like stay constant, right? So it means that you just like from one neutron, you get another one neutron, you get another one neutron, you get another one neutron. So makes sense, right? So let's say if you got 4 neutrons being released, 4 neutrons to begin with, then in the end you just have 1 neutron left, right? So then it can keep maintaining a steady reaction. So it means that there will be 3 neutrons extra that we don't need. So it means that the total number of the NC and the N1 should be equals to 3. So what could be the answer here? Yeah, that should be the C, right? So why is not be D? You chose D, right? D, if you got the NC is like 2 per fission, so it means that you taken 2 neutrons out of the reactors. There's only like 2 left, right? And if there's also like 2 neutrons being lost, so is there any neutron left? No, you end up with a 0, right? If it's just that the remaining is 0, then you don't have any reactions going on. It means at this time the reaction will be stopped. This is when you want to like shut down the nuclear reactor, right? So it cannot be D. For the B, the same thing as well. And this one even like a lot of lost, like 3. That really a huge ratio, 1 to 3, right? So that should be something wrong with the walls of the reactor that we need to fix it. And for this one, if one is being observed out and one is being lost, so what left is like 2. So imagine that after one reactor you got 2 more, and then this little one here have another 2, this one have another 2. You can also see that after a while it will be increasing with a 2 to the power n, right, which is kind of huge, and then we cannot keep it under the control. It cannot be a steady reaction. Steady reaction means that it does not change. If you just got 1 and then it keep going just like 1, 1, 1, and 1. So that's why the best answer here is the C, okay? And another thing to take note of this one is that the average number of neutrons being observed should be more than the being lost, right? If there's a lot of number of neutrons being lost, then there should be something wrong with the nuclear reactor, and we need to double check. Okay, so C is the answer. Please let me know if you have any question. Thank you.